Hello, my name is Lei Li from Language Technology Institute at Carnegie Mellon University. My research is on multilingual natural language processing and large language model and using AI to discover a new drug. So today I would like to talk a little bit about my research on multilingual natural language processing. Our goal is to cross the barriers of 1,000 languages in the world so that we can develop technology for people to communicate freely regardless of language. So there are 5 major topics in my lab, including multilingual NLP and translation, AI for content generation, neuro-symbolic reasoning using large language model, and trustworthy large language model. And lastly, using AI to discover new drug molecules to cure diseases. So we know there are language barriers, which is a major issue for communication, international education, remote Medicare, foreign tourism, and international trade. So we want to develop technologies for people to communicate easily across all these domains. The current technology of machine translation is far from perfect. However, they are very useful. For example, for international trade, machine translation has already increased international trade by 10%. But there are more languages that cannot be solved by current machine translation system. There are around 7,000 languages in the world. Many of them are spoken by people from understudied languages, and those are the people who need most help. So the research in my lab targeted at solving technologies for people to communicate for those understudied languages. Traditionally, neural machine translation takes the input sequence and use a transformer model to generate a translation on the target side. But to train this model well, we need a lot of data. And there are many languages don't have enough data to train high quality model. So our research will focus on those low resource languages where we have limited resource and we want to develop high quality multilingual natural language processing techniques. So here's some examples of the work in my lab, including vocabulary construction, model training, evaluation, deployment, serving across all aspects of machine translation. I wish to highlight the 3 cases of the current recent research in my lab. The first one is how can we construct an optimal vocabulary for machine translation. So traditionally, we can break the sentences into smaller units by word or by character, or units in between word and character. However, they are not necessarily optimal. In our recent work, in a paper appeared in 2021, we developed an algorithm called VOLT. We provided an information theoretical algorithm to find optimal and cost-effective vocabularies for machine translation. This work received the ACL Best Paper Award in 2021. The second work is on many-to-many multilingual neural machine translation. For multilingual machine translation, we want to develop a single unified model that can translate many language directions at the same time. This involves zero-shot language directions and unsupervised direction, where during training time, we don't have direct parallel sentences to train. So this requires our model to be highly adaptive to new language directions. Into our recent work, we developed two algorithms, MRASP and Lego MT, that can translate between 50 to 440 languages. In particular, Lego MT, we developed a model with 1.3 billion parameters that can translate over 400 languages. That's the largest coverage of the number of languages right now by a single machine translation model. Another related research topic is speech translation, where we want to translate audio or speech in the source language to the target text. The challenge is we only have limited speech translation data, and we also need low latency and high performance for real-time translation. In our recent works, Const and WACO and MOSST, we developed a series of algorithms to translate in real time and with high translation quality for speech translation. Another related work is on machine translation evaluation. Where in the past, when we want to evaluate the quality of the machine translation generated result, we often ask human annotators to rate the candidate for us, comparing to the reference. So in this project, we aim to develop learning-based metric that is highly aligned with the expert. It's unsupervised, so it doesn't require human reading to learn. And it's generalizable to any languages around the world. So in our recent work of instructor score and SE score, we developed methods that can identify major errors or minor errors from candidate translation sentences, comparing to the reference. And we assign different score to them so that we can differentiate the severity level of these errors. So this method is widely used in industry, and it's already open sourced on Hugging Face for public use. In addition to machine translation, I'm also working on efficient machine learning, trustworthy large language model, and AI for drug discovery. So our goal is to develop efficient and effective algorithm that can generate a sequence of discrete tokens in the case of natural language, or discrete structures in the case of drug molecules. That's all for my research. Thank you for your attention.